Hey, good morning. All right, I'm past the last video, but that's not done either, just because. All right, elemental abundance, and now it's isotopic abundance. But if you were old school taught the periodic table of elements, it was talked about how much of those elements there are on the earth, and this is called elemental abundance. So, somewhere in your periodic table, yeah, I know, and information about elements, there is numbers that have been built over decades and decades called isotopic abundances. The rules for creating these numbers have changed, have been refined, but they've only gotten better. So when you see something change in those numbers, you can go chase out and find why something changed. There will be a paper somewhere. It might take 2 years to find that paper somewhere, but usually there's a reason for a change, or the paper would be retracted or redacted or changed or whatever to be made correct, because maybe in a year or two those processes go through and happen because somebody else tried to use the equation and it didn't work. Anyway, isotopic elemental abundance. So as we learned more, as the instruments became more accessible and people learned about isotopes, this is decades still. We've known about these for a very long time. It's part of the bomb thing. It's before my generation started, so this is not new, not my fault or yours. So this is abundance of the raw materials of life. Um, we know how much carbon is on this planet. We have a very good number of the amount of carbon on this planet, of the amount of hydrogen on this planet. We can measure it in the soil, we can measure it in the air. So there are a lot of different ways these numbers are derived. And if you go look at them, the numbers are so small for some of them because there's just not much around. Um, Helium's a good example. Now, it turns out we do have a way to manufacture helium from nuclear byproducts, but it's not enough to supply what we use, and we're getting helium out of the earth that's still being made. So, elemental and isotopic abundance. Who cares about these things? Um, Anybody doing any type of spectrographic research, of um, spectrometries. So there's labs have been doing this for a long time. You can go see those isotopic abundance numbers. Now, why does this matter? Well, I want uranium. I'm going to go look at the USGS data that they so conveniently put together. I might have to pay for it because now it's on the other side of the paywall somewhere and I can't see these because I can't afford to. But I'm going to go look at this science of the planet, and I'm going to look for isotopic abundance for uranium. And I'm going to go to that nation and I'm going to try to buy their uranium, and I'm going to try to buy it goddamn cheap. I might tell them it's, I'm going after clay. They have no idea what the hell I'm going after in that dirt. I'm going to make sure their thoughts and prayers have nothing to do with real life. So isotopic abundance, that's one reason it matters. This is how the mining industry goes about selecting where to make a mine. They drill, they take samples, they see how much of something is down there, and when they get that percentage, it might be point zero. Look at uranium, look at cesium, look at any of the elements out there. Um, See, the difference is your original thinking around the periodic table of elements was that's all there was, until those isotopes came in. And the isotopes began to show that all elements are not forever. They came from someplace, they have a half life, or they have a life. We know about half of it. So that is a way roundabout about isotopic abundance. I'll put a link, it's in my front page, but I'll put a link to a periodic table and one of the places you can find this information. Now, if you go further, you can find molecular numbers, right? How much water is on the Earth? What percentage of water is on the planet versus the percentage of solids versus the gas? Now, the gas measurement, that might have just blown up. What's in our atmosphere? The way that calculation was done, because we had defined our atmosphere as stopping at some point between here and the moon. When, some people know it didn't, but it's not worth the argument because the physics at that looser level works, but when you get closer. So, having extended the atmospheric boundary of our planet could have affected the isotopic abundance measurements for numbers in near space. Again, I mentioned it somewhere else. If you know the elements are there, you can go harvest them. If you know the molecules are there, if there's water is a molecule, it's not an element. It takes an H and two O's and a little bit of energy to happen, and it stays water for the most part. But remember, water evaporates, and it also can be split at some minor rate from the energies from the sun. So it these isotopic abundance numbers, they are constantly being checked and updated because the ground rules change. The reason you'll see a change almost always is accuracy. We just got better at doing something. So isotopes matter. Um, as a point to support my theory, isotopes matter, elements matter. The second U.S. government agency after the Army was not the State Department, it was the USGS in the Middle East. All of those invasions were followed up with a good mineral survey, because what's a good mineral survey among friends? That is why we're there. Isotopic abundance, elemental abundance, particulate abundance, human abundance, these are all factors in this thing we call life. And some folks are trying to get us there. Many paths, many roads. Peace out.